Hello children, today we are going to study about chemistry concepts, language of chemistry. This is for standard 8, 9, 10. All students can watch and you can also make a revision of what you have been studying. Now first I'll talk about the elements and types. Elements, what are the elements? We have spoken about elements are found in nature and they can be these elements are 118 elements that we have found till now, and 92 elements are from the nature. 92 elements, the elements we find in air, in the atmosphere, under the earth, under the earth's crust, and then as O's and all these things. So, and rest of the elements out of 118, 92 are natural elements given by the nature to us, and rest are man-made elements. Now, that is seen in the periodic table. So, after that, elements are how many types? Elements are of how many types? They are metals, they are non-metals, and metalloids. So these things we are going to study one by one: metals, then non-metals, and the metalloids. Then comes the next thing, that when these elements were found in nature, the scientists, the great scientists, all the scientists, Dalton, Berzelius, then came one by one, all the scientists who came and worked on it, they found that these elements were having very big names. Suppose for hydrogen is having a very big name, hydrogen. Writing hydrogen all the time is so difficult. Oxygen, it's very difficult to write oxygen all the time like this. So Dalton was the first person who gave some structures. For hydrogen, he gave a structure of a circle with a dot. Then oxygen, he just gave a circle. Then for sulfur, he gave something like this, and so on and on. He gave, but these diagrams again were very time taking and they were not so easy to use. So what happened is, another scientist came, Jacob Berzelius. He suggested a very easy method, that is giving abbreviations or short forms to these elements. And so they said that for elements can be given short forms. How the short forms were given is in the form of, suppose for hydrogen, it is the first letter of the word hydrogen, H. For oxygen, O. For sulfur, it is S. Okay, fine. But for carbon, if it is carbon, then it is again, carbon is C. In this way, elements were given name. But carbon C, calcium is also C. So what to do? First letter is C. So second letter has been taken. So after calcium C, the small, a very important thing, first letter has to be capital letter and the second letter has to be small letter. If you write for calcium Ca, then it becomes wrong. Then comes chlorine. Chlorine is again also CH. Chlorine. Here, see, if you put only C for chlorine, then carbon has C, symbol of carbon is C, then how will you differentiate? So C small l. If you write C and capital L, this becomes wrong. So this is how the elements were given symbols. Now all the elements were given symbols. Out of these some were given from the Latin word. Some elements were given Latin name first. Those Latin names, from those Latin names, the symbols were given. And so these elements were the ones which we are going to study. That these elements are symbols of these elements. First is gold. Gold, OU, aurum. Silver has been given as Ag, argentum. Then comes the next one is the suppose gold, silver, gold, silver, mercury. Mercury was given Hg. This is hydrogyrum. Hydrogyrum. Then comes antimony. Antimony is Sb. Then stbium. Then for tin, Sn, sternum, like this. Then comes after tin, it is you can take silver, aluminium, antimony, then lead. Pb is lead. Then comes the next one. In this way you will get some elements which had been given the names of the elements, and they were they came from the words. This is sternum, then plumbum, and all these things had come. And then came the other one, that is all these came from the Latin words. These are all Latin names. These are all Latin names. These are Latin names given. Then there are 11 such elements which you will get in your textbook in 9th standard and 8th standard also. And then comes, after getting these elements, right, giving symbols to these elements, then comes a very important thing that we should know, that these symbols have some atomicity. What is atomicity? Atomicity means like number of atoms present in a molecule. Atomicity. We have done with elements and symbols. Now atomicity, what is atomicity? Atomicity is number of atoms present in a molecule. For example, if I write only hydrogen, this is one atom. If I write oxygen, one atom. If I write sodium, one atom. But here a very important thing is, for hydrogen oxygen, we usually don't write hydrogen oxygen like this. Hydrogen comes in the form of H2 and O, oxygen O2. So these are diatomic. So before we go to diatomic, first thing that I would like to tell you, number one is monoatomic. Monoatomic. Now when monoatomic means, mono means one, monoatomic means here the metals, then the noble gases or inert gases, and carbon. These are all monoatomic, because metals are which one? Lithium, sodium, potassium, magnesium, calcium, whatever we are going to study, all these things, aluminium, then these are all metals. Now from there we come to another very important thing, that is the second one is diatomic. Di means two. So diatomic, which elements are diatomic? Non-metals are diatomic. Non-metals. Example, oxygen, hydrogen, then nitrogen, then comes, because we don't write OHN like this. When we represent oxygen, we write O2, H2 or N2. Then comes all the halogens, 17th group of the modern periodic table. So this will be fluorine, chlorine, bromine, iodine, astatine, all these things. Now this way we will study the diatomic. Then comes triatomic. Which element can we find triatomic, or which molecule is triatomic? There is one molecule, that is ozone, which we will be studying is O3. When we write ozone, it is written in this form O3. That means 3 atoms of oxygen is present in one molecule of oxygen. So here what then comes for fourth one, phosphorus. This is triatomic. Sorry, I wrote it like this. You write triatomic. Triatomic is ozone. This is ozone. Then tetraatomic. Tetraatomic is phosphorus. And last one we here, suppose sulfur, we write sulfur is octaatomic. Sulfur is octaatomic. Octaatomic. So here S8, sulfur comes in 8 atoms together. Here a very important, when you study about this, a very important thing that you should also remember, that when you write one molecule is equal to 2 or more atoms. When a molecule is formed, a molecule is formed by 2 or more atoms. It cannot be one atom. One atom is one atom. It is not a molecule. When it comes to 2 atoms, then only 2 atoms or more than 2 atoms, then only one molecule is formed. This is one. Now, a very important information that I would like to give you, that till class 10, we are going to study for ICSE students, that we are going to study the elements from 1 to 20. Now these elements, are I have written in a very small form. Can you see? See, hydrogen has got atomic number 1, helium has got atomic number 2, lithium has got atomic number 3, beryllium 4, boron is 5, carbon is 6, nitrogen is 7, sulfur is 8, then fluorine is 9, neon is 10, sodium is 11, magnesium is 12, aluminium is 13, then comes silicon is 14, phosphorus is 15, then after phosphorus, sulfur is 16, then chlorine is 17, and helium, neon, argon. Argon is 18, then potassium is 19, and then comes calcium is 20. All these 20 elements we are going to study mostly. In between, when you see the periodic table, if you have the textbook, when you watch or view such videos, you should always have a notebook with you or a textbook and a pen, pencil, whatever. And then you should always see that, see, in chemistry periodic table you will find these elements in this form. First two, there are 18 groups. First two groups are metals. Then in between, now 1 and 2, then 3 to 12 we don't study in till 10th standard in such a broader way. But some elements will be taken for in reactions or somewhere will be needed. And then comes 13 to 18. All these elements will be studied in this in our course from 8 to 10. Now here, all these elements, see, hydrogen has got 1 atomic number. I have given you the atomic numbers because we are going to study about the valency. Atomic numbers are very important before we study the valency. I can just tell you the elements and the valency also. That is fine. You can mark them up by hearted. But then I feel that instead of just by hearting or trying to remember in this way, if you understand and then you study, then your understanding process will be much easier and faster. So for today, this much only, students. So in the next video, I am going to talk about the atomic number and a little bit of atomic mass, atomic structure, and then I'll start with the valency and things will be quite clear for you. Thank you.